Hello. So the question is from Iit Jam 2022. So the question is saying the consider the differential equation it is given, double derivative plus a y of this, say first derivative of y plus y equal to sin x for x belongs to this R real space. So I have to find which one of the following is true. So we can rewrite this equation plus 1 equal to sin x. From here we can find the value of d. So this d will be minus a. So this, if we consider this equal to 0, okay, so this is 0. So from here we can find the, so we can just write it in this way, is equal to 0. So from here d equal to minus a plus minus a square minus 4 by 2, right? Now if we put the value of a equal to 2, so the option D here can see this a equal to 2, what will be the value of d? So d will equal to minus 1. It is minus 2, so it will be 0, minus 2 by 2 minus 1. So the complementary equation can be written as c1 plus c2x to the power e to the power minus x. So we can see the option D, that if a equal to 2, then the solution of this particular differential equation are bounded over minus infinity comma 0. So if here x tends to minus infinity, what will be the y complementary? It will tends to infinity, plus infinity. So this shows that yc is unbounded. It is not bounded within this particular interval minus infinity to 0. So whenever this x is tending to plus infinity, yc will tends to minus infinity. Same case, the yc will be unbounded. So here which one of the following option is true? So D is not correct. Let us check with this a equal to 1. So what will be the value of D? D equal to will be minus half plus minus root 3 by 2i. Okay, you can write the particular this integral y of p as 1 by d square plus d plus 1 sine of x. If we consider d square as minus 1, so it will be 0, so it can be written as, since 1 power is there, sine x is there only, so 1 by d sine x. Okay, so integral is this, in 1 by d means integral of sine x minus of cos x. Now we know that the maximum value and the minimum value of cos x ranges in between minus 1 to plus 1, right? Now check the options with this. So if a equal to 1, then the solution of this differential equation tend to 0 as x tends to infinity. So as x tends to infinity over here, you can find this. So the value of cos x is not tending to 0, because the maximum value is in this case 1, minimum value is minus 1. So it will be in here in between. So you cannot determine this cos x value will tend to 0. It will either tend to -1 or the maximum value +1. Within this range it can. So the option C, you can, this, it is false. And similarly for the option B, if a equal to 1, then the solution of are unbounded over 0 to infinity. So it is already saying that the solution of the particular differential equation, we know that cos x is bounded, it is not unbounded, right? Cos x is not unbounded, so this option B is also not true. It is not unbounded over the 0 to infinity. Cos x is bounded within this interval of -1 to 1. So option B is also incorrect. So it's the option A, if a equal to 0. So let us check with this. So if a is equal to 0, then we can write the equation as d square plus 1 y equal to sin x, right? So d will be, so d square plus 1 equal to 0, so d will be plus minus I. Okay, so now what will be the complementary equation? This y of c will be simply, so this is I, so c1 cos x plus c2 sin x. And what will be the yp? So yp is d2 plus 1 sin x. So we can write it also in this form if we do the derivative over here. Okay, so d2 okay, so we can write it x by 2d of sin x, derivative over both sides. So we'll put an x over here. So now doing the integral, so it will be minus x by 2 cos x, right? So what will be the general solution? General solution will be yc plus yp. So in our case c1 cos x plus c2 sin x minus x by 2 cos x, right? So here you can see that at the let's check the condition over there. Okay, the condition is saying that if a equal to 0, then the solution of uh, sorry, what is this saying? This so if a equal to 0, then the solution of the differential equation are unbounded over this real space. So now if a, now when you can do equal to 0, we got the general solution. Now at fx, if I find that if here, so now if x tends to infinity, so from here we can write this x tends to infinity, so the general solution is y equal to yc plus yp. So as x tends to infinity, y will tends to minus of infinity, right? Similarly the vice versa will be there, x tends to minus infinity, y will be tends to plus infinity. So for all values of c1 and c2, because it is still unknown these values, so for every values of c1 and c2, y will be unbounded. Okay, so it is the correct option for that a equal to 0. So it is unbounded over the region R, this real space. So in our case, for question 23, the solution of this equation is A, correct option. The question number 24. So let G be belong to this integer set of integers, and G complement this particular integer of 37. Set of integers denote the residue class G modulo 37. Okay. So consider the group. We have a group with respect to the multiplication modulo 37. So we have to find which one of the following is false, right? So if suppose if P is prime, and if we consider a group as UP, so we can write it. So this UP to the power n is isomorphic to Z P to the power n minus P to the power n minus 1. So here we have the U of 37. It is isomorphic to Z 37 to the power 1 minus 37 1 minus 1. So it is isomorphic to 36, right? So now what are the elements in this particular 36, Z36? One of the element will be the 0, the identity element, and another is 18. Because why it is 18? It is a self inverse. You can see that 18 is equal to this 18 inverse. So if you do this identity, this addition modulo 16, so if we are using this addition modulo, it will be 0, right? So element in this Z36, it is showing that only two elements are there, 0 and 18. We have to find the false one. So already the option A is correct. This contains exactly two elements. Let us check with the option B. The order of the element in particular U37 group, this element is 36. So we can write it in this way, this 36. So this is the element 10, this element, and the order of this is 36, it is telling. So let us check this. So if we multiply it 18 times at this, in this addition model, this in this we have to 18 times, so it will be 180, that's the total summation. And if we divided it by 36, it will leave remainder as 5, right? So the order of this, there is no remainder, this the quotient will be 5, this just so this 18 times, so the order of this particular element, you can say that 10 is 18, not 36. So the correct option, this our in our case is 36. The false option is B. So let us also check with the C and D. So in C it is saying that there is exactly one group homomorphism from U7 to Z plus. So we can write it in this way, that so U of 37 is isomorphic to three six. So how many? So we need to find the group homomorphism to Zn plus, right? Right. So from here, so in this particular group, So one element is a finite order. That is the identity element. Okay. So this is only the finite element order, and every other element will be infinite order. So from Z36 to how many group homomorphism will be there? So it will find it from GCD 36, 1, 1. So that is saying that there is exactly one group homomorphism. So this is a correct answer, correct option. And there is also one group homomorphism from Q1 plus. Okay. So similarly we can write in the similar way that U of 37 isomorphic to 36, yes, Q and plus. So we can take a Z as a subgroup. So this will be a subgroup of Q plus, and one of the element will be this same finite order. So we can write it as this Z1, right? So in going from 36 to Z1, how many group homomorphism will be there? GCD of 36 plus 1, 1. So here also exactly one group homomorphism is there in going from this U37 to Q plus. So we know that for the option, the question number 24, the correct option will be order of the element 10. In this particular 36, it will be 18. So option B is the correct option.